Welcome to AI Waves channel, your go-to spot for demystifying the complex world of artificial intelligence. Before we dive into the fascinating realms of machine learning and deep learning, make sure you hit that subscribe button and ring the bell so you won't miss any of our cutting-edge AI content. And remember, while we strive to provide accurate and up-to-date information, the field of AI is rapidly evolving, so always seek out additional resources to stay informed. Now, let's get started. Have you ever wondered how Netflix always seems to know what show you'll binge watch next? Or how your email filters out spam without you lifting a finger? The secret behind these marvels is a technology that has been steadily transforming our world, artificial intelligence, or AI. AI is a broad field that encompasses several technologies, but at its heart, it's about creating machines that can think, learn, and make decisions in ways that mimic human intelligence. And while the concept of AI might conjure up images of futuristic robots, the reality is much more subtle and pervasive. AI is the invisible hand guiding a multitude of processes and systems we interact with every day. From the personalized recommendations on your favorite streaming services, to the predictive text on your smartphone, to the voice-activated assistant that sets your morning alarm, AI is hard at work. It's powering advancements in fields as diverse as healthcare, finance, transportation, and entertainment. It's helping businesses become more efficient, making our lives more convenient, and even tackling some of our world's most pressing challenges. But what exactly is AI? And how does it work? Well, AI can be broken down into two main categories: machine learning and deep learning. These are the engines that drive AI, the technologies that enable machines to learn from data, recognize patterns, and make decisions, all with minimal human intervention. Machine learning is where it all started. It's a subset of AI that uses algorithms to parse data, learn from it, and then make predictions or decisions. Deep learning, on the other hand, takes this concept to the next level. It's a subset of machine learning that uses something called neural networks, complex algorithms designed to mimic the human brain, to learn from large amounts of data. While machine learning and deep learning are integral parts of the AI landscape, they each have their strengths and weaknesses, and they're each suited to different types of tasks. In the coming segments, we'll delve deeper into these fascinating technologies, exploring how they work, how they're being used, and the incredible potential they hold. Today, we're unraveling the mystery behind these technologies. Imagine teaching a computer to play chess. Instead of coding every possible move, you provide it with historical game data to improve over time. This is the magic of machine learning, a subset of artificial intelligence that uses algorithms to parse data, learn from it, and then make a determination or prediction about something in the world. So instead of hand-coding software routines with a specific set of instructions to accomplish a particular task, the machine is trained using large amounts of data and algorithms to learn how to perform the task. Now you might be wondering, how does this learning happen? Well, machine learning involves feeding data to an algorithm, which uses it to build a mathematical model. This model is then used to make predictions or decisions without being explicitly programmed to do so. Like a child learning to walk, the algorithm stumbles and falls at first. But with time, it learns from its mistakes and gets better. Let's delve a little deeper into the types of machine learning. The first one is supervised learning. Here, the algorithm is trained using labeled data. That's like showing a child a picture of a cat and saying, "This is a cat." The child learns from these examples and eventually can identify cats on its own. Similarly, a supervised learning algorithm learns from examples to make predictions about unseen data. The second type is unsupervised learning. This is where the algorithm is given a bunch of data and told to find patterns and relationships within it. It's like giving a child a box of Legos and watching what they build. They might sort them by color, stack them by size, or create intricate structures. Similarly, unsupervised learning algorithms find hidden patterns or intrinsic structures in data. Lastly, we have reinforcement learning. This is learning by trial and error. Picture a child learning to ride a bike. They pedal, wobble, fall, and then get back up. Each time they fall, they learn something new about balance and control. In the same way, a reinforcement learning algorithm learns by interacting with its environment. It takes actions, gets rewards or penalties, and adjusts its strategy accordingly. Machine learning is a powerful tool, but it's not a one-size-fits-all solution. Choosing the right type of machine learning depends on the problem at hand, the nature of the data available, and the desired outcome. Yet, regardless of the type, the essence of machine learning remains the same: learning from experience. It's about gleaning insights from data, spotting patterns, making predictions, and enhancing decision-making. It's about teaching computers to learn from the past to create a smarter future. So, the next time you're amazed by a personalized recommendation or a smart assistant's response, remember, it's all thanks to the wonders of machine learning. Deep learning, a subset of machine learning, draws inspiration from the human brain, specifically neural networks. Just like our brains are composed of billions of neurons that transmit information, deep learning operates on artificial neural networks. These networks consist of layers of interconnected nodes, or neurons, that process and transmit data. Deep learning models can be thought of as a multi-layered information processing system. Each layer takes in the output of the previous layer, processes it, and passes it on to the next. This layered structure allows deep learning models to learn complex patterns and relationships in the data they're trained on. Now let's get a bit more technical. Each neuron in a deep learning model takes in data, applies a mathematical function to it, and passes the result onto the next layer. The strength of the connections between neurons, called weights, are adjusted during the training process, which is how the model learns. But what really sets deep learning apart is its ability to automatically extract features from raw data. In traditional machine learning, features need to be manually extracted and selected, which can be a time-consuming and complex task. However, deep learning models can learn to identify important features on their own, given enough data and training time. This automatic feature extraction capability is one of the reasons deep learning has been so successful in areas like image and speech recognition. Let's take image recognition as an example. When a deep learning model is trained on images, early layers might learn to recognize simple shapes and colors. As you move deeper into the network, layers might learn to recognize more complex patterns, like textures and parts of objects. And in the final layers, the model might learn to recognize whole objects based on these parts. And it doesn't stop there. Deep learning is also behind some of the most exciting advancements in natural language processing, including translation and sentiment analysis. It's even making waves in the world of art, with models that can generate music, paintings, and even write poetry. Deep learning isn't without its challenges, though. These models require large amounts of data and computational power to train, which can make them impractical for some applications. They can also be difficult to interpret, as the learned relationships between inputs and outputs are hidden within the layers of the network. This is often referred to as the black box problem. Despite these challenges, the potential of deep learning is immense. Its ability to learn from vast amounts of data and handle complex tasks makes it a powerful tool in the world of AI. Deep learning models can tackle more complex problems, from diagnosing diseases to powering autonomous vehicles. So, while we may not fully understand every detail of how these models work, their ability to learn and adapt makes them an integral part of the AI landscape. So how do machine learning and deep learning compare? These two subsets of artificial intelligence, while closely related, have distinct characteristics and uses. Let's break it down. Machine learning is like a clever student who learns from textbooks, following the examples and exercises provided. This student can learn and adapt to new problems based on the knowledge they've acquired. Now imagine deep learning as a curious explorer who learns not just from textbooks, but also from observing the world, analyzing patterns, and drawing conclusions. This explorer can tackle more complex problems based on their broader learning. Both machine learning and deep learning learn from data, but the amount and type of data they require differ. Machine learning algorithms can work with smaller data sets, learning from carefully selected features. On the other hand, deep learning algorithms thrive on big data, learning to identify relevant features by themselves from raw, unprocessed data. This autonomy is one of deep learning's main advantages. It can handle vast, complex data and perform tasks like image and speech recognition with impressive accuracy. However, this power comes with a cost. Deep learning requires substantial computational resources and time to train, often requiring specialized hardware like GPUs. On the flip side, machine learning, while not as powerful, is more accessible and versatile. It can run on common hardware and work well with smaller data sets. This makes it a practical choice for many tasks, especially when computational resources are limited or when you're working with less data. Each has its strengths and weaknesses, and their use depends on the problem at hand. For tasks like spam detection or customer segmentation, machine learning is a solid choice. But for tasks like autonomous driving or disease diagnosis from medical images, deep learning shines. In conclusion, machine learning and deep learning, while sharing the common goal of learning from data, approach this goal differently. Deep learning models require significantly more data and computational power to train, making machine learning a more practical choice for problems with limited data or when computational resources are a concern. Both machine learning and deep learning are revolutionizing industries. These technologies are not confined to the pages of research papers or the labs of tech giants. They are alive and thriving in the real world, making a tangible impact on our everyday lives. Let's explore some of these real-world applications, starting with machine learning. One of the most widespread uses of machine learning is in the realm of personalized recommendations. Whether it's the movies you stream on your favorite platform or the products suggested to you on an online shopping site, machine learning algorithms are at work. These algorithms analyze your past behavior, compare it with others, and then predict what you might like, making your online experience more personalized and engaging. Machine learning is also a game changer in the healthcare industry. For example, predictive modeling is used to identify high-risk patients, enabling early intervention and potentially saving lives. Machine learning algorithms can analyze vast amounts of medical data, identify patterns that may be overlooked by human analysts, and predict health outcomes. Now let's shift gears and delve into the world of deep learning. One of the most remarkable applications of deep learning is in the field of computer vision, the technology that allows computers to see and understand visual information. Deep learning algorithms are used in self-driving cars, where they help recognize traffic signs, pedestrians, and other vehicles. Deep learning also plays a crucial role in natural language processing, which includes tasks like language translation and sentiment analysis. For instance, deep learning powers the technology behind popular voice assistants, enabling them to understand and respond to our voice commands. Another compelling application of deep learning is in the creation of deepfakes. While this technology can be misused, its positive applications are noteworthy. For example, it can be used in the film industry to de-age actors, recreate historical figures, or even bring back actors who have passed away. Let's take a closer look at a few specific case studies. In the finance sector, machine learning has been instrumental in preventing fraud. Algorithms are trained to detect anomalies in transaction data that may indicate fraudulent activity. This enables financial institutions to react swiftly, protecting their customers and themselves from financial loss. On the other hand, deep learning has been used to develop voice assistants that can understand and respond to a wide range of commands. These voice assistants, found in smartphones and smart home devices, are becoming increasingly accurate and natural sounding, thanks to the continuous learning capabilities of deep learning algorithms. In conclusion, machine learning and deep learning are more than just buzzwords. They are transformative technologies that are reshaping industries and improving our lives in countless ways. Machine learning algorithms help financial institutions detect fraudulent transactions, while deep learning is behind the stunningly accurate voice assistants in our smartphones. As we've seen, machine learning and deep learning are not just buzzwords. They represent powerful tools that underpin the technological advancements we witness every day. Machine learning, with its ability to learn from data and identify patterns, is transforming industries, making our lives easier and more efficient. Deep learning, a subset of machine learning inspired by the human brain's architecture, is pushing the boundaries even further, tackling complex problems that were once the exclusive domain of human cognition. In this video, we've unraveled the mystery behind these technologies, breaking down their complex workings into understandable concepts. We've explored the various types of machine learning, from supervised to unsupervised and reinforcement learning, each with its unique approach to learning from data. We've delved into the fascinating world of deep learning, with its layers of artificial neurons that process data, mimicking the human brain's ability to learn complex patterns. We've compared these two subsets of AI, highlighting their strengths and limitations. While deep learning can tackle more intricate problems, it requires more data and computational power, making machine learning a practical choice for problems with limited resources. Moreover, we've seen how these technologies are revolutionizing industries. From detecting fraudulent transactions in the financial sector to powering voice assistants in our smartphones, the applications of machine learning and deep learning are as diverse as they are impactful. But our journey into the world of AI doesn't stop here. There's a whole universe of knowledge waiting to be explored. As the field of AI continues to evolve at a rapid pace, it's crucial to stay informed, to keep learning, and to keep questioning. So we encourage you to delve deeper, to ask questions, and to challenge what you know. Join us next time as we dive deeper into the fascinating world of AI. Until then, keep exploring, and remember, the future is AI.